everybody, and welcome back to the Fur and Fam YouTube channel. In this week's episode, we're going to get into the details of our electrical system. We've got all our components laid out here. We're going to talk a little bit about each of them, how they interact with each other, and the reason we picked them out. So, let's get started. So in order to decide how we got to all of these components that you see here on the table, you can actually take a look at one of our previous videos. We'll put a link to that in the upper right hand corner, I believe. And basically that video will walk you through how to size an electrical system in a van, how to pick out what components that you need. I believe it takes you through 7 steps in order to get the system where you want it to be, able to run all the components that you want in your van, and able to do it safely. So take a look at that video. If you're past that, if you know how much capacity you need within your system, what size inverter you need to run, the size wire that you need to buy in order to meet code, all those things, then you're ready for this video today. So we're going to kind of dive in here, and basically if you've been following along on the channel, you'll know that I reference my red book a lot. The red book is basically the van design guide that I'm writing as I go. I think we've pretty much decided that we're going to take everything out of this book, turn it into a nice friendly PDF, and basically be able to share that with you as we go along. So check out our website, furandfam.com. We'll be uploading that once we get done with it. So basically stay up to date there. In the next videos, we'll let you know how we're coming along with it and when it's ready for you to take a look at. So basically, getting into the electrical system here, we're going to kind of work backwards, and I'm going to actually take the camera off the tripod and give you a little closer up view of everything that we're working on as we go. Alright, so what we've got here is our AC distribution box, our AC circuit breaker, and all of our AC wiring. And basically this is the distribution center for all of the AC loads in the van. So anything that's running 120 volt is going to come through this box. Now, the protection is the circuit breaker. So we've got a circuit breaker for every circuit that we're going to run. And second to that, the circuits that will be near water or around water will have GFI outlets on them. There's 2 ways you can do that. You can either run a GFI circuit breaker to protect the entire circuit, or you can put the GFI outlets where you know there's going to be water. In our case, we only needed like 2 GFI outlets, so it really didn't make sense for me to spend the extra money and buy a bunch of GFI breakers. I'm just going to put those in where we need to. As far as the wiring goes over here, this is marine wire. The reason I'm using marine wire is 1, because it is very corrosion resistant and it's made to stand up in harsh environments. 2, it is not a solid core wire. That's very important in a van. You do not want to run solid core wire in a van, because solid core wire is made to run in your house, which does not move. The reason is, if solid core wire vibrates, it will generate heat and could potentially short out and cause a fire. So that's the last thing you want in your van. We're running 12 gauge wire, and it's inside an insulated jacket in order to prevent it from rubbing or getting cut on anything as we run it through the van. That's the other thing. In a house, you're running through wood stud walls, so typical like Romex wiring that you find running through your house is not rated to what this wire right here is rated for. So I spent the extra money, got the marine grade multi-conductor wire to run all of our AC loads. I went with 12 gauge solely because the AC unit is going to be on a 20 amp breaker, and it's going to pull close to 15 amps, so the 12 gauge wire will be able to handle that load. I could have probably gotten away with 14 gauge wire and run 15 amp breakers on all my other circuits, but since I had to buy a 100-foot roll, I went ahead and got 20 amp circuit breakers to run 12 gauge wire everywhere. That way we'll be completely covered on the 120 volt side. And the next piece is the inverter charger. And now that basically takes the AC power, the DC power, and turns it into AC. It also does the inverse of that and will charge the battery when you're hooked up to AC power. We chose to go with a Victron Multi Plus. It's a 24 volt system, and we'll get to that when we get to our battery pack, the reason why we chose 24 volts. It is a 70 amp charger and is a 3,000 watt inverter. So we'll be able to basically charge our batteries and run our AC off of our batteries, do anything that we need to do through this inverter. Victron, definitely a well-known name in the power industry. There's a lot of boats that use Victron. There's a lot of RVs and camper vans that use Victron. It's also something that's used in stationary power. So like if you had a battery pack at your house hooked up to a solar system, a lot of people would run a Victron energy inverter to power their entire house if they needed to. Another good thing about these Victron inverters, if for some reason we ever realized we needed more than 3,000 watts of power, which don't think we ever will, but like if you get sized where you think you're going to need more, you can run two of these bad boys in parallel with each other and have plenty of energy to run all the things that you need to run. So that's something to keep in mind with a Victron system. Another reason we went with pretty much all of our components are Victron is because, one, you can configure them through the Victron app and set up how you want to charge, which we'll get more in depth in that when we get to our battery. And that was another main contributing factor of why we chose a Victron unit, for that configurability and flexibility there. And the rest of the components in our system, they will all talk to each other and communicate because they're all on the Victron system. So that's the inverter charger. That's what's sending power to our 120 volt appliances and other things. Another neat thing that this inverter charger does is it has a switch inside of it. So when you hook up to AC power, it will actually not run through the battery. So you can have a direct AC out that will basically isolate your battery and only run your 120 volt appliances through the shore power connection. And that'll be handy for things like our fridge. That is a 12 and 120 volt fridge, so we'll run off the battery when we're not hooked up to shore power, and as soon as this is hooked in, it will then click our fridge over to run 120 and not pull energy from our battery. So let's go a little bit now, take a step back and go through our DC side of the system, which is a little more simple. And so we're going to go back over to our DC distribution panel. And basically all this is a marine grade fuse block from Blue Sea Systems. You can find those in a lot of marine applications. It's a name that is very well known in the marine world. And out of this fuse block, we are running the same Deca Marine Master tinned wire for the same reasons that we discussed about the 120 volt wiring. And basically, this is just only 2 conductors instead of having a third for a ground. And it's 16 gauge to run our lights. We're going to use some 10 gauge wiring, or maybe even 12. I haven't really quite decided yet on which one I want to run there to run the rest of our heavier, like the fridge, and higher amperage draw, like the water pump, the fridge, those kind of things. But the same Marine Master, marine grade, probably the best you can buy, bang for your buck wiring. That's all going to run through our fuse block here. So now as we're taking a step back, getting one step closer to the battery, we've got our day green step-down inverter. This is, I think, the only main electrical component that is not blue and has Victron on it. Basically what this unit does is takes a 24 volt input and turns it into a 13.8 volt output. And the reason it's not exactly 12 volt is because a lot of 12 volt appliances actually run better on 13.8 volts. If you look in your car, whenever your car is running, it does not run at 12 volts. It typically runs at close to 14 when it's charging the battery. So all the 12 volt appliances, if you up the voltage just a little bit, they'll pull slightly less amperage, and usually you get a cleaner running 12 volt appliance or light bulb or anything else. We're going to try to do as much 12 volt appliances in the van as we possibly can. So going back through the system a little bit, on the other side of our step-down inverter, we've got our thermal fuse here, or actually it's a thermal circuit breaker. And basically this circuit breaker will protect everything downstream through the step-down inverter, through our fuse block, and through our wiring to all of our main components. So this is an 80 amp resettable circuit breaker. The other thing this can be used as is a switch to disconnect everything that's on this side of the system. So if we want to disconnect it from the battery, you hit that button and it throws the switch, and you're now disconnected and you can service the other part of the DC side of this system. So this basically will then tie into a bus bar, which will then go to our Victron battery disconnect or battery protect. And the reason that we're running this is because we are running a Tesla battery module. And we're going to get a little bit more into that, the reasons why you're going to need this battery protect here in a second. On the other side of the battery protect is a 500 amp inline fuse. And that is the final piece of protection that basically, if anything overloads this battery and pulls more than 500 amps, we've got a serious problem, and we want that fuse to blow and protect our battery.
After filming this video, we've done a little bit more research on our battery module, and it turns out that we're going to use a 250 amp fuse in this location. Reason being, if you're discharging at a rate higher than 250 amps, the Tesla battery module has the requirement that it needs to be cooled. You'll exceed the thermal limits of the pack, and that's not a good thing. You'll melt it down and could potentially start a fire.
Kind of moving more towards the battery, we've got our battery monitor here from Victron, and basically it calculates how full the battery is, sees the state of charge, can tell you what percentage you're at, how much you're using, all those kind of things, and it'll be wired in close to the battery and will give us all that information. So that brings us to our Tesla battery module. And we went with a Tesla battery module because it is the most bang for your buck when it comes to lithium battery components. You can do BattleBorn batteries, but you're going to pay about twice as much for the same storage capacity that you get in one of these Tesla battery modules. Another thing that I like about them is the size. You can see it's a relatively thin module. It is long, but it gives you a great opportunity to place them in places where BattleBorn batteries would not fit. You can also chain as many of these together as you like if you need more energy storage. What we're going to do is start with this one here that is a 250 amp hour at 24 volt battery. And that's another thing. At first when I was looking at this, I was like, oh, it's not really that much more capacity. When you double the voltage, you have the current that you need. So really this is equivalent to a 500 amp hour 12 volt battery. And so that's where the real savings comes in. If you're on the West Coast, you can look at EV West for purchasing this battery. This is where this one actually came from. And then once I did some more research, I actually found there's a place in North Carolina called HSR Motors, and they actually source Tesla battery modules as well. And HSR is a little bit cheaper than EV West, but both of them, it's still a used battery module out of a car. It's not brand new. That is one risk that you take with these modules. You don't know exactly where they came from, but with the energy density that they have, I thought it was worth the risk to do it. Another thing about these battery modules is the nominal voltage is actually not 24 volts. The nominal voltage is around 22 to 23 volts. That's, I guess, the middle range voltage. You can charge it all the way up to 25 volts, but it's not advised to run a Tesla battery module up to 25 volts. You'll substantially shorten the lifespan of the battery. And so we're going to have our configurable inverter charger over there set up to charge up to about 24 volts and discharge down to about, or actually our battery protect is going to be set to shut the battery off if it goes below about 19.5 volts. So that will save it and will allow it to basically protect itself. If you overdrain one of these batteries, you can run into some serious issues there. Another thing that you have to keep in mind if you're going to run a Tesla battery module is you really need a way to balance the cells. So that's where this comes in. This is a Venom Pro Lipo checker, and basically it's got a 6S connector on it. I'm going to have to do some soldering between this end because this connector is not compatible with the Tesla battery module connector that comes on it. So I've got the wiring schematic for both of these units, and I'm going to solder this connector, or really these wires, into these wires here, and that will give me the ability to balance the different cells within this pack and make sure that I don't have cells going bad or things of that nature. So those are basically the main points on the Tesla battery module. Another thing that you need to be conscious of is you're not supposed to charge or discharge a Tesla battery module if the module itself gets below freezing. Really, the charge rate needs to be slowed as you approach, I believe, 45 degrees Fahrenheit.
And these requirements are why we chose to go with Victron components. They're configurable. Basically, you can set the charge rate to adjust for lithium-ion batteries. There's a temperature input that will go into our inverter charger, and then it will go across the VE bus, which connects the different components together, and let the inverter charger know that it needs to change its charge rate and or stop charging if it gets below a critical temperature. This is also the same logic that's used on the DC to DC charger and on our charge controller. So that makes it where we have to worry less about the charging components, and also the inverter charger is smart enough where we can set a voltage disconnect where it will stop discharging the battery at a certain voltage. So the Victron Battery Connect, it's a solid state relay. It's only intended for stopping the flow of current in one direction. The posts are labeled input and output, and this is because, like I said, it's not intended for charging and discharging. It's only intended for current to flow in one direction, like I said before. So basically we've only got it between our DC loads and the battery now in order to protect the battery in a case of being drained too far. So going back to the issue of temperature and keeping the battery warm enough,
the way that we're going to combat that, there's two schools of thought there. Some people will use the coolant fittings on either end of the battery module and actually run antifreeze through it and run an aquarium heater and a little water pump to cycle coolant throughout the battery and keep the battery warm when it is cool outside. The other school of thought is to use a electric heating blanket and basically set it on a thermostat to maintain the temperature that you want in your battery. So that's basically the heart and soul of our electrical system. The one thing that you don't see on this table is our solar panel, our solar charge controller, and our roof penetration box. Those are things that we're going to add in later, and what we're going to do is use a Victron charge controller and probably LG monocrystalline panels. So whenever we get our solar system rigged up and ready to rock, we'll definitely do another video on how to install all of that. Another thing that we're going to do on our van to charge, so we've got our inverter charger that will charge from shore power hookup. We'll have our solar panel and solar charger like we just talked about. And the final piece of our electrical system is actually on the other side of the table over here. And this is our DC to DC charger. This allows us to charge from the alternator of our van. And what it'll do is it will bring in a 12 volt signal from our van. It will convert it to a 24 volt charge output, and then it will charge our battery. And so that's one thing. While we're driving down the road, we'll have 15 amps at 24 volts going straight into our battery if it needs it. This guy is fully configurable with Bluetooth. You can see a little Bluetooth light there. So you can set it up to have the same charge characteristics as our multi-plus unit that we're going to be using to charge with shore power. That also brings into play where our another 30 amp circuit breaker is. It will be between the charge controller here and our battery over there. So that will act as the switch and act as a circuit breaker if need be. The other thing we're going to do is anywhere that we don't have a resettable circuit breaker, we're going to use a Blue Sea battery switch. This is a very common battery switch used in a lot of marine applications, and so that's basically going to be our disconnects everywhere that we don't have a resettable circuit breaker. So that pretty much covers all of the components that are going to go in our electrical system that will allow us to travel in our van and hopefully never have to hook up to shore power and be able to run all the things that we need for day-to-day life, basically. Another thing that you don't see on this table is all the wiring that connects each device back to the battery and the bus bars. The reason that I don't have that is because I'm going to go ahead and mount all of these components in their location, and then from there I'll be able to get a length for each cable and better determine how much I need of each cable. Because when you start getting into bigger gauge, heavier gauge wire, you don't want to just order 100-foot rolls of it and only use 4 feet of it to run from the battery to the fuse. That would waste a lot of money. So I'm going to go ahead and get everything mounted in the van, in our garage area, and get it all where I want it, make sure everything fits, and then figure out the wire links from there, and either order pre-terminated wire with the lugs on each end to attach to all the terminals like these that you see here, or either get terminals and crimp them all on myself or solder them on myself. So that's something, like I said, you don't see that wire on this table, and that's the reason why, because I don't want to waste a lot of money and get a bunch of cable that I don't really need. The other thing about all these components is you can buy almost all of them off Amazon. So if you want to check out the links below in the description, we'll have a link to every single one of these components, except for we did not order our wiring, and we actually got our breaker box for our 120 from Lowe's. You can get a similar one from Amazon, so we'll put a link below to that. And then the Tesla battery module, obviously you can't buy from Amazon because it is a used battery module, but we'll put the links below to EV West and HSR Motors. So if you want to check those guys out and get a Tesla battery module to use in your van, you can get it from those places. Definitely stay tuned as the red notebook gets turned into the van guide. We'll keep you all updated and let you know what to expect there. It's going to have wiring diagrams, cabinet layouts, how-to guides on how to make cabinets, how to frame out a van. Pretty much everything you've seen in the videos, we're going to try to include in that guide in a one readable place, basically, so you can get all the information in one place. If you have any questions about anything that you saw in this video, any of the components, why we chose any of the components, make sure you leave us a comment below with that question. We'll definitely get back to you and try to answer it to the best of our ability. If you enjoyed the video, make sure you hit that thumbs up button down there. That definitely helps our channel out. If you want to see more of our videos, we're trying to release a video roughly every week. It's a little hectic now between life and van building and editing videos and all that stuff. So we're working towards getting one every week, but it's not guaranteed that there'll be a video every week. But definitely check back to the channel every now and then, and hopefully you'll find a new video. Like I said, we're going to try to stick to a week, and we'll see how it goes. So hit that subscribe button, turn on the notifications, and it'll let you know when we put a new video up. So thanks everybody for watching, and we hope to see you back at the channel next time.